I welcome you all in the course Unit Operations of Particulate Matter. Today we will start this course, and the first lecture of this course, that is the introduction. As this course is about unit operation of particulate matter, this figure speaks about what we are going to study, that is nothing but about the particles. So, here I present the unit operations of particulate matters, and the unit operation of particulate matter in chemical engineering, it involves the handling and processing of particulate solids. So, here as you have seen that in this particular course we are dealing with the particles. It presents the unit operations in chemical engineering that involves the handling and processing of particulate solids or particulate matter. Now, as far as this particular session or this particular course is concerned, the primary features of this course is it covers the most important operations involving particulate solids. So, here basically we will discuss different unit operations which are involved to handle and process of particulate matter. It describes the characteristics of powders and particulates. Now, what is the meaning of this characteristics of powders and particulates? That is, here as far as characteristic is concerned, that we can understand in terms of size and shape of the particle as well as its density or etc. So, once we characterize the particle, we will define its size, shape, density. Now, in this particular course, we will see the effect of size, shape and density on the particular operation we are going to discuss. The third feature is explores common bulk solids processing operations including sedimentation, filtration, fluidization and flotation. So, as far as unit operation is concerned, we will cover a main unit operation, that is sedimentation, filtration, fluidization and flotation. So, this particular course presents the operations relevant to the transportation of solids, that is after discussing these particular unit operation, 4 unit operations in detail, we will discuss the operation which are involved for transportation or carrying the particle from one place to other place. When we discuss about the particle, I am discussing the bulk of particles, that is the total particulate matter. Now, if you consider this particular slide shows what? It has different words like pharmaceutical, manufacture, crystal, droplet, powder, nanoparticle. From this figure you can identify what are the different application of this particular course which involve the handling and processing of particulate matter. So, here we can define the unit operations of particulate matter. It deals with science and technology of solid material, which is a multidisciplinary field including material science, environmental, biomedical, aerospace, agricultural, chemistry, microbiology and cell science, pharmacy and medicine. So, here you can see the course that is unit operations of particulate matter. Its application is not in chemical engineering, but it is used in many other fields also, and that fields are really wide. So, this particular course is useful for many fields in which engineers or the person work. Now, as far as we will define further what is exactly the unit operation. Before we have defined the unit operation of particulate matter, it means which deals with the particulate matter. Now, here we are defining the unit operation itself. In chemical engineering and related fields, unit operation is basic step in a process. Unit operations involve a physical change such as separation, crystallization, evaporation, filtration, sedimentation, etc. Now, here if you see this statement, this speaks about the physical change in the process. So, here I have to clarify that unit operations deals with the physical change in the process, not the chemical change. What I mean with the chemical change is when any reaction is carrying out in the process. We are not going to discuss the reaction which is carrying out, but the physical change. When we consider the example of crystallization, what happens here is the supersaturated solution converts into the solid particle, solid matter. What happens over there? There we have only the physical form of the component, physical form of the content will change. Initially it was at supersaturation liquid at that stage, and now it is in the solid state. So, that is nothing but the physical change in the process. So, that therefore, this type of process or this type of operation we called as unit operation, where reaction is not involved. And similarly, in evaporation what happens, water vapor, water or let us say not only water, the solvent releases from the slurry, the solution. So, that is nothing but from conversion from solution state, conversion from liquid state to vapor state. So, that is nothing but the physical change. So, all physical changes are involved in chemical engineering, and that are clubbed in one section, and that section is called as unit operations. So, when we consider a particular operation, it has many unit operations. For example, if I am considering milk processing, it has homogenization, pasteurization, chilling and packaging. So, these are different unit operations which are involved in manufacturing of milk, and a process may require many unit operation to obtain the desired product from the raw material. So, you can see in any process there are many unit operations involved. However, these unit operation does not consider the reaction. When we consider the reaction in any process, we call as unit process, not as unit operation. Now, that here we have already defined the unit operations. Now, before starting this the details of unit operation of particulate matter, we have to see the history where we are actually identified the unit operations in literature. So, as far as history is concerned, Arthur D. Little used the concept of unit operations to explain industrial chemistry processes in 1916. So, here you say the first literature about unit operation we have got in 1916, where the unit operation is used at industrial level. Now, further in 1923, William H. Walker, Warren K. Lewis and William H. McAdams wrote the book The Principle of Chemical Engineering and explained that the variety of chemical industries have processes which follow same physical laws. They summed up these similar processes into unit operation. So, here we again have seen the physical law which are applicable to the process, and they are clubbed in one word or one section that we can refer as unit operations. So, here we have some literature where the unit operation is actually used in actually appear first time. Now, each unit operation follows same physical law and may be used in all relevant chemical industries. For example, here we have seen the same physical laws will be applicable to the relevant chemical industries. Now, what is the meaning of this? For example, if I am going to design a mixer which mixes two component or maybe three component together. So, when we are designing a mixer, whether we design the mixer for a lab scale or for industry or for one process or for other process, this design will follow same physical law. It means the design equation will be same, only scale up and the other condition will be applicable. Mostly the physical law will be same when we are going to design a mixer for different conditions, for different application I should say, like when we are going for laboratory, when we are going to design this for industry. So, in this here we have defined the history which is appear in the literature. Now, it is basically the reported history. Now, once we see this in our day to day life, you can understand that from how long we are using the concept of unit operation in our day to day life. To illustrate that, I have taken the example here in this particular slide. You can see this figure. Now this figure speaks about powder technology in ancient Egypt, illustrating the threshing process. Now if you consider this particular figure, here persons are involved in threshing process. Now what is threshing process? Threshing process is basically to remove the edible material from the waste. Like when we remove the cereals from the its scaly waste, that we also called as husk, so that we can remove. So if you consider this particular figure, the person who is standing over here, he has some screening tools through which the edible cereal will be collected, and the waste scaly material that we also called as husk, that is quite light in comparison to the cereal, so that can be screened from this, and due to the effect of wind, it will be collected away from the cereal. So cereal will be collected from one side, another side we have the collection of husk. So the person which are these two person which are at slightly bending position, they are basically collecting the cereals as well as husk separately. So if you consider this particular picture, this is taken from this is basically a wall painting in the tomb of Mena. So this is very old picture. Now this picture speaks about that it is as old as mankind and has been used in a broad field industrial activities such as food preparation, ceramics, glass and building technology. Some people consider particle technology as a second oldest profession of the mankind. So you can see over here that this particular unit operation is used since very beginning, where we were aware with this or not, but we were using this concept since many years or many decades. Now here if you see, we have used the word powder technology, and in this particular course we are introducing unit operation. So that is nothing but the synonym of unit operation. Other synonyms are particle technology, particulate engineering, mechanical operations, all these are synonyms of the unit operation. So when I speak about particle technology, powder technology, mechanical operation, I am doing nothing but I am speaking about unit operation itself. Now let us consider few more example from the history. If you consider this particular figure, that you understand very well, this is nothing but the henna, we also call it mehndi. Now if you see this figure, here what happens, how this mehndi or henna is prepared. If you see this, initially we collect the henna leaves, and then that these leaves will be crushed and crushed to the very fine size, and then it is mixed with the water to make the paste. Now when we are crushing this, so what we are doing basically is we are involving unit operation in this, because that is nothing but the physical change, that is from higher particle size, that is in terms of leaf, we are converting this into the lower particle size, that is the powder. So here we have involvement of unit operation. Now the history and origin of henna is hard to trace. With centuries of migration and cultural interaction, it is difficult to determine where particular traditions began. So you can understand from how long we are using henna, that we are not aware, but henna has been used in India since around the 4th and 5th centuries. So this is a quite old data. So you can understand from how long we are using. Now this particular figure, it speaks about different spices. So as back as 3000 BC in India, turmeric powder, spices powder and Ayurvedic medicine made up of powders using particle technology were used. So since very beginning we are using this unit operation in our day to day life, whether we were aware with that or not, but we were using it. Now here you see, if this particular figure, what is this? This I think we all are aware with this. This is nothing but we use this to prepare the spices in our houses. Even I have seen this in my house since my childhood, and you also have seen. So this is nothing but we can say an arrangement, we can say an equipment which involve unit operation to convert the size, higher size particle to lower size. So, that is nothing but the physical change. So, we can say that it can be a unit operation. So, here this is basically Indian stone grinder. In the second figure, in this figure where the shape is quite oval type, this is Sudanese stone grinder. So, the old traditional method of grinding the grains in India and Africa, which was widely used until 20th century, was crushing them by stones. So, here you see 20th century data is available over here, and since many time back from this we are using this stones to crush the material. So, here you can say that we are using unit operations since many decades. However, in 1916 it appears first in the literature as far as industrial application is concerned. So, that was about the history of unit operations. Till now you can understand unit operation is basically the physical change, and unit operation basically involve the particulate matter or solid. Now, why we are defining this course, that is unit operation of particulate matter? Particulate matter, why we are considering? Because you all are aware that around 75% of chemical manufacturing processes involve small solid particles at some point. So, we have used the particles in our day to day life, and as far as chemical processes are concerned, they also use this extensively. So, proper design and handling of these fine particles often makes the difference between success and failure of the product. Now, why I am calling this success and failure of the product depend on the particle size? To illustrate that, I will give a few example in subsequent slide. Now, as far as particulate matter is concerned, it prepares different products such as catalyst, pigments, fertilizers, cements, ceramics and pharmaceuticals. They are currently manufactured with the particulate forms. So, in chemical industry, for example, more than half of the products and at least 3/4 of the raw material are in granular form. So, here you can understand the particulate matter, they are considered in industrial scale significantly. Now, further, if we consider the particle that can have a definite shape, but we are considering the number of particles. So, particles in fact do not behave as solids, their behavior is somewhat near to liquid. How we can say that? Because when we consider when we consider a number of particle size in a glass, and when we tilt the glass, it will be tilted. So, it can take the shape of the container, and it can change its property as the property of liquid changes. So, therefore, we can resemble the behavior of this with the liquid. So, as material becomes smaller from submicron scale to a nano scale, their electric, optical and magnetic properties change extensively. So, what is the meaning of this? That when we consider different particle size, their property changes, and therefore, it behaves differently when we consider different particle size, and therefore, its the failure and success of the product depends on the particle size, because it changes the property of the material. Now, as far as optimum particle size is concerned, there is an optimum particle size, or at least a smallest and largest acceptable size for most items involving particles. A few examples I am considering over here. The first is the taste of chocolate is affected by the size of their respective ingredients. To illustrate that, I will speak about the particle size of chocolate in the subsequent slide. So, you can have the idea how the taste changes. Secondly, extremely fine amorphous silica is added to tomato ketchup to control its flow. So, here you can understand the extremely fine silica we add. So, that is nothing but the a very small particle size, or that optimum particle size which controls the flow of the ketchup. And similarly, pharmaceutical tablets dissolve in our system at rates determined in part by particle size and exposed surface area. Now, to give an example of this, if we purchase the crocin, that is very common tablet, if we purchase the crocin and consume this, even I have experienced this many a time, that sometime the crocin reduces the temperature and sometime it does not affect. So, what is the reason of this? Because composition of crocin is same, company is same. So, what is the difference? Difference is the particle size they are considering. They consider not the optimum particle size, which takes the optimum time, or which takes minimum time to react. So, here we can see the effect of particle size, even the tablets, which I think most of us consume. And finally, we have the settling time of concrete, dental filling and broken bone casts proceeds in accordance with the particle size and surface area exposure. So, all these will depend upon the particle size, optimum particle size basically. So, here if we consider in this slide, there we have the range of particle diameters in different products. Like if we consider the chocolate powder, the optimum particle size is 8.83 micrometer, and similarly for other material. Now, if you consider the particle size of chocolate powder, what we have this optimum particle size, the taste of chocolate is affected by the particle size, as we have seen in the last slide. Now, why we are saying that? Because when we consider a smaller particle size, it basically controls the viscosity. When you can understand, when we are considering very fine particle size, it behaves as a liquid. So, when the particle size is very small, its viscosity is controlled in such a way so that it spreads in the mouth and give the mouth feel. So, based on that we can say that the chocolate is having a mouth feel or not, and accordingly we have different taste. If to give an example, if we consider the chocolate of very fine particle size, and we have the mouth feel, these days we have experienced mouth feel in different biscuits also. For example, if I take the biscuit, that the very famous biscuit, and that we call as dark fantasy. If you consider that biscuit, and when we break this, when we have this, then it has liquor inside this. So, that liquor is basically the very fine particle size chocolate, and when we consume this, it gives the mouth feel. The coating of the biscuit will not give the mouth feel, only the chocolate which is inside. So, that has a particular optimum size, and that optimum size gives the mouth feel. So, therefore, the particle size will be depending upon the whether the product is acceptable by the consumers or not. For example, dark fantasy, if we consider that, we like a lot because of the mouth feel, and similarly the eclair chocolate, when we consider, it also has the mouth feel, and sometimes we have seen in TV the advertisement like chocolate ka meetha bomb, we call that. So, that bomb is nothing but when we have the mouth feel of chocolate, and that we can find through very fine particle size. So, here you can say the particle size will depend upon whether product is acceptable by the consumers or not, or in other word, whether the product is successful or not. So, the previous slide statement, if you remember, that we have seen the particle size affects the success and failure of the product, and this is one example of that. Now, another example, here we are considering the wheat. We all consume wheat. Now, if you consider this particular figure, here this figure shows the wheat, the raw wheat, or we call it the cereals. Now, if consider one particle size, this particle size may be of length by 5 mm, 6 mm, or sometime 4 mm also. When we consider this, when we consume this wheat, it will not be easily digestible because of its size. In this figure, we have another product from the same source, that is the wheat, we call this as dalia. That is nothing, this dalia is nothing but the smaller size of this wheat, and you can understand that when we have this smaller size wheat, it is very healthy food because of this particle size, because it considers the fibers, protein, etc. This also consider fibers, protein, but due to its size it cannot be taken directly. So, we reduce the size of the particle of wheat to make the dalia. Another product of the wheat is semolina, we also call it suji. So, that you can understand that is nothing but the product of the wheat of different, it has a smaller particle size than dalia. It will be used in making pastas, etc., and that is also very healthy food. Now, further when we consider the product of wheat, that is where we all are aware with this, that is nothing but the atta that we use in our daily life, and that is also contains fiber, protein, carbohydrate, etc. So, that is again the healthy food. And finally, we have the product that we call as maida. So, that is very fine particle, but it is developed, it is prepared with the wheat itself. So, it is basically just a carbohydrate content of the wheat, and it is free from vitamin, fiber and protein. So, you see this, when we consider this maida, it has very less particle size, so that fiber, vitamin all are removed from this and only carbohydrate is remaining. So, therefore, this is not healthy food as far as our consumption is concerned, but we have this in different product. So, you can understand that from this wheat we have derived 4 different products, that is dalia, suji, atta and maida. So, all 3 are healthy, but maida is not healthy. So, that depends on the particle size of a particular product, of a particular material, in which particle size we are consuming, so that it can help us. And here we have different industries which are using particulate matter. So, these are coal chemicals, ceramic, potassium production, synthetic fibers, fertilizers, explosive, paint, glass industries and many more. So, you can understand this particular course is applicable to many industries. Now, further we consider the unit operations. What are the different unit operations available? So, in chemical engineering, unit operation consists total 5 categories or 5 classes. The first class is the fluid flow processes. It includes fluids transportation, filtration and solid fluidization. Second class is the heat transfer processes. It involves evaporation and heat exchange. Third category, mass transfer processes. It considers absorption, distillation, extraction, adsorption and drying. These are different unit operations which are involved in the mass transfer processes. Now, fourth category we have is the thermodynamic processes. It includes gas liquefaction and refrigeration. The fifth category is the mechanical processes, which consider solid transportation, crushing and pulverization and screening. Now, among these 5 category, in this particular course we will speak about the fluid flow processes as well as the mechanical processes. In fluid flow processes we consider filtration, fluidization, sedimentation and flotation, that is the fluid flow processes. And in mechanical processes we will discuss the solid transportation. So, these 2 unit operations are involved in this particular course. Now, for this particular course the target audience would be the undergraduate students. However, this course will also be helpful for anyone of any professional level, preferably he or she should have the college degree or substantial experience, industrial experience, who can work or who has already worked in the production, handling, processing, modification and transportation of particulate matter. So, all persons who are involved in this, they can join this course. Objectives of this course is to identify the important physical mechanisms occurring in processes involving particles, to formulate and solve mathematical descriptions of such processes, to apply this knowledge to the design of particulate systems such as sedimentation tank, filtration unit, fluidization unit, flotation cell, etc. So, these are the different objectives of this particular course. Now, this particular course basically covers sedimentation. You can see in from this diagram that if we need to collect the thick sludge as well as the clarified liquid, clarified solvent, so we can go for the sedimentation process. Second is the filtration. Filtration, we all are aware with that, that is we have the filter media and the particles which are falling in this, if it has larger particle size than the media opening, it will be blocked, otherwise next rest will be passed through this media. So, that is nothing but the filtration. We all have used the filtration in our labs when we have the funnel, when we have the filter paper, when we have the test tube. So, here this particular figure shows the filtration at laboratory scale. Another topic is fluidization, where solid particles are fluidized with the help of air and liquid. Fluidize means they will be considered in flowing, they will be transported in flowing state from the static state. Further, we will consider the flotation. This particular figure we will I have only shown to give you the idea what is flotation, that when material floats over the liquid surface, that we call as flotation. Now, this second figure speaks about the particular operation as far as chemical engineering is concerned. So, we will consider the flotation, and then finally, we will consider the transportation of particulate matter, that is how the solid material is transported from one part to another part in plant as well as away from the plant also. And here we have some of the references which we references in terms of books, the books which we are going to refer for this particular course. These are 5 books. Other thing we have also considered like some web pages etc. So, that I will speak when it will appear in the at that time I will speak about that. So, these are the few references. Now, here we have the summary of the video. The course unit operations of particulate matter is defined along with its industrial application. The importance of the course is discussed while highlighting its utility from ancient time to present days. The effect of particle size on product quality was discussed, and unit operations covered in this course was briefed. So, here this is the first lecture where you have the idea what is unit operation of particulate matter, what is its application, what was its history, and what is its utility in our day to day life. So, I think you have enough idea at the end of this introductory class that why you are going to study this course. It has utility in our day to day life as well as at industrial scale also. So, that is all for now. Thank you.